Okay, so we're going to still be using Euler's formula to kind of derive this. So if we have r cosine theta plus I sine theta, we're still going to use the fact that this is equal to e to the r times e to the I sine, sorry, r times e to the I theta. So what happens if we raise this to a power? Right? So if this is our complex number, z to some power, if we use this form, it's pretty easy to see what happens, right? This is equal to r to the n times e to the I n theta, right? Which we could write as r to the n times cosine of n theta plus I sine n theta, right? So you can remember and use this form, but if we use Euler's formula, it's really straightforward to see where it comes from, right? And what happens if we take a root instead? If we have z to the 1 over n power, okay, well, that's just going to be r e to the I theta to the 1 over n power. So that's going to be r to the 1 over n power, e to the I theta over n, right, if I multiply that exponent. And I can just write that as r to the 1 over n cosine theta over n plus I sine theta over n. So basically, it's really the same thing, right? In this case, we're just multiplying n. In this case, we're dividing by n, depending on what form our exponent is in. So so just so you know the name of this is de Moivre's theorem, okay? It's stating exactly what we did, okay? But just in case, just so you're familiar with that terminology, this is de Moivre's theorem. I don't think any of the homework asks for it in that form, but they might. All right, so let's do an example. Evaluate this expression, 1 plus I to the 5th, using de Moivre's theorem. Okay? All right, so in order to do this, we have a few options here. We have a few options here. One is we could multiply this out times itself 5 times and see what we end up with. That seems like a pain, but not impossible. The other is that we could write this in polar form and raise it to this power. Okay, so how are we going to do that? Well, we're going to need to know what our theta is and what our r is, right? So how can we find our r? Well, remember our r is the square root of x squared plus y squared. So our x is our real value, our real part. Our y is our coefficient of our imaginary part. Coefficient is the word I couldn't remember a few videos ago. So this is going to be square root of 2, right? R is square root of 2. And how about our theta here? Well, let's see. This is going to be over 1 and up 1. This is 1, this is 1. So here's our theta. So we can say, well, tangent of theta equals 1 over 1. So what do we know from our table? We know that theta is going to equal pi fourths. Right? The arctangent of -1 is pi fourths. All right, so now we can write this in exponential form. We could write this as square root of 2 times cosine of pi fourths plus I sine of pi fourths, which we could also write this as square root of 2 e to the I times pi fourths. Right? And now if we raise this whole thing to the 5th, I guess we should probably raise this whole thing to the 5th, we're going to get square root of 2 to the 5th power times e to the I 5 pi fourths. Right? And if we want to write this in a less awkward way, we could write this as 2 to the 5 halves, right? And now we could write this as cosine of 5 pi fourths plus I sine of 5 pi fourths. And those are values that I can evaluate, right? I know what cosine, so 2 to the 5 halves. I know what cosine of 5 pi fourths is, or at least I can think about it. It's going to be negative square root of 2 over 2 plus I. This is sine of 5 pi fourths will also be negative square root of 2 over 2. Okay, this is going to be, let's see, interesting. So let's think about this as 5 to the 2/5. What is this really? This is a negative 2 to the negative 1/2, right? If we use those, plus 2 to the 5 halves, or I times 2 to the 5 halves. And this is minus, same thing, 2 to the negative 1/2. So I have the same base. I'm going to add the exponents, and I'll get negative 2 squared, right? 5 halves minus 1/2, plus or minus I times 2 squared. So I'll get minus 4 minus 4I. Is that right? Is that what they got? Yes. Okay, so let's see. Our problem started here. Let's think about what we did. We said, okay, I've got a complex number raised to an exponent. It would be nice if I could use de Moivre's theorem, but in order to use de Moivre's theorem, I have to have this in polar form. So I had to find my r and I had to find my theta. So I wrote it in this form. I use this Euler's form because it's easier with exponents, at least to me. But really, I mean, is this easier? I don't know. It's easier to see where it comes from, but really we could go right from here to here if we remembered that we just multiply, raise this to that exponent, and then multiply both of these angles by 5. Whichever is easier for you. If it makes sense to go into this form, do it. If it makes sense for you just to remember that I'm going to multiply each of these angles by 5 and raise this to the 5th power, here we are. And now we just evaluated these. And there might have been, maybe it would have been easier to leave this as square root of 2 to the 5th. I don't know. I made things a little bit complicated by writing this with a rational exponent. But then we just multiplied it out, right? This was just multiplying things out until we got this form of our number. Would this work if we just multiplied 1 plus I times 1 plus I and did that 5 times and then just did all of the distributing and didn't make any mistakes? We would get this same number, okay? But I mean, what if this exponent was really big, like 90? Definitely wouldn't want to do that, right? But we could use de Moivre's theorem to evaluate that in a straightforward way. All right, so let's practice finding a root of a complex number. Evaluate the cube root of this complex number. So this is already in polar form for us, so that's handy. We want to find z to the 1/3 power. So we could write this in r e to the I theta form, or we could just remember that we're going to raise this to the 1/3 power and then divide our angle by that power. Oops, this will be 9, right? Because it'll be 3 times 3. And this is 2. I don't think we know cosine of 2 to the pi ninths. Should we cheat and look? What do? Do they leave it that way? Okay. I am going to pause this for a minute and figure out this problem, and I'll be right back. Okay, I was trying to make this too easy, so let's do it the right way. Okay, so here's actually what we have to do for the nth root theorem, for the nth roots. So here's the nth root theorem. Not only do you have to divide the angle by n, okay, we need to add 2k pi over n. So 2 pi over n for different values of k. So in this case, we have a third root. So we're going to need to let k equal 0, 1, and 2. Okay, so we're going to get 3 answers. Okay, one where k is 0, one where k is 1, and one where k is 2. Okay, so here's the form of all of our answers, kind of what I said, but more complicated. Okay, so this is one of the roots if k equals 0. Okay, this will be one of the roots. And so that's what they say. There'll be 3 roots when k equals 0, 1, and 2. So if k equals 0, we have, what we thought here. Okay, but let's look at what happens if k equals 1. Okay, so if k equals 1, we still have 2 pi ninths here, but we're going to let k equals 1. We'll have 2 pi thirds. Right, they're adding 2 pi thirds, but they're finding a common denominator. So they're changing 2 pi thirds into 6 pi ninths and adding that. So 2 pi ninths plus 6 pi ninths, we get 8 pi ninths and 8 pi ninths. Okay. Now what if k equals 2? We're going to be adding 4 pi thirds to each angle. But when we find the common denominator, 4 pi thirds becomes 12 pi ninths. Right, so we add these together and we get 14 pi ninths. So those are our 3 answers. Okay, the simple one. And then where we let k equal 1 and k equal 2. Okay, so this is our second solution and this is our third solution. I think on your homework you have 1 or 2 problems, because these are kind of long, 1 or 2 problems where you have to find nth roots of complex numbers. Okay, this is complicated. It's a little bit peripheral to the main idea of the course. So I wouldn't stress too much about this, but I do want you to know how to do it. I mean, obviously, since my first go, I didn't get all 3 answers. I just got the 1. This isn't like a key point of this course, but I want you to know how to do it. And this isn't that bad, right? You can do this for finding nth roots.